Have you ever wondered what refractive index means? If yes, then this video is for you. But before that, I would like to talk about my friend Karthike. My friend Karthike was once driving a car at 80 kilometers per hour inside vacuum. And this is his position at t equal to 0 seconds. You can observe the front wheels A and B here in this position. Now what happens is that he sees a muddy road in front of him and he decides to go through it. And this is his position at t equal to 1 second. The wheels have just started to enter the muddy path. And this is his position at t equal to 4 seconds. The orientation of the car remains exactly the same, but the speed of the car drastically reduces for some reason. Now, while on the way back, he traverses the same road, and from the muddy path, he goes inside the vacuum. And he sees that the speed of the car increased. He went and reported to our friend Kathan about this. And now my friend Kathan, being a show-off, decided to drive the car obliquely. And this is his position at t equal to 0 seconds. But what happens in this case is that at t equal to 1 second, the wheel A reaches the boundary of the two mediums first, and B is still inside vacuum. And he expects that this is going to be the orientation. It's just going to go straight down obliquely. Nothing is going to change. But he expects that the speed is going to reduce, but the orientation to be the same. But that does not happen. Instead, what happens is that the orientation of the car changes. Now, it may be linear or it may be at an angle with the normal, but you can observe that it is at a small angle compared to before. That is, the car bends towards the normal. They decide to try this experiment with different mediums, with oil, with water, with air, with different mediums. And they find out that the denser the medium is, the more the speed of the car is going to reduce. And whenever you ride in a straight line, the orientation of the car remains the same, but if you drive obliquely, both the speed and the orientation changes. They come and report all of this to Devika. And Devika explains what happened in this particular scenario. So you can see that A has reached the boundary first. So A starts to move with a slower speed than before. But the wheel B, still being inside vacuum, moves faster, which creates a rotational effect, and which is why this changes the orientation of the car. Now, my friend Devika doesn't stop there. She decides to apply the same things, same observations with light. She decides to test with light now. She turns on the torch and strikes a beam of light at a medium. So this is her inside air, and she strikes a beam of torch, and exactly as she expected, the angle of the light changes when it is oblique. When it is sent in a straight line, the angle of the light does not change. However, the speed changes. In this case, both the speed and the angle changes. So she concludes some things about light with different mediums. She introduces a term called refractive index. Now, what refractive index means is that it is the tendency of a medium to slow down the speed of light. The higher the refractive index, the lesser the speed of light. She found out that the denser the medium is, or in this case, we call it optically dense. The more optically dense the medium is, the lesser the speed of the light and the higher the refractive index. That is, refractive index and speed of light are inversely proportional to each other. In fact, V equal to C by N, where C is the speed of the light in vacuum and N is the refractive index. The speed of light in vacuum is approximately 3 into 10 to the power 8 meters per second. Alright. Now, once we have got the terminology refractive index, we can get back to this experiment. So she called the refractive index of the air as N1 and she called the refractive index of the water as N2. She started the torch and sent the beam of light, and as you can see, this is the incident angle with the normal and this is a refracted angle with the normal. Kathan had expected the light to keep on going at the same incident angle, but as Devika had explained to him, the angle should have changed, and it does change in this particular example. But she doesn't know how to predict whether the light bends towards the normal or away from the normal. And then Karthikeya comes back after studying and tells her about something called Snell's law. What Snell's law does is that it gives them a relation between the incident angle, the refracted angle, and the relative refractive indices. Why relative? This is called relative, or this is called relative because it compares the two refractive indices of the two mediums. Alright? So this relation gives us an idea whether the light is going to bend towards the normal or away from the normal when it is moving from one medium to the other. Now, Karthikeya dived inside water, and this time he sent the beam of light obliquely from the water towards air. And he sees that the refracted ray, the refracted angle was more than the incident angle in this particular case. As we would have observed in this particular example, the same thing exactly happens with light. So this thing is called Snell's law. This relation is called Snell's law, and it gives you an idea about the incident ray and the refracted ray and their angles with respect to the relative refractive indices. For example, if you want to find out whether the refracted angle is going to be more or lesser than the incident angle, let's understand from this relation. Sin r is equal to n1 by n2 times of sin I. And we understand that sin theta is an increasing function. Therefore, the more n1 by n2 is going to be, the greater r is going to be with respect to I. Alright? Or we can say that whenever a light is moving from a rarer medium, what rarer medium means? Rarer means less refractive index. Whenever the light moves from rarer to a denser medium, optically denser medium, then as you can see, the light bends towards the normal. And when the light is going from a denser medium to a rarer medium, it bends away from the normal. Now how you can find out is with the help of the Snell's law. So that was the basics of what a refractive index is and how you can estimate or find out the refracted angle. Thank you.